A single discovery this year could rewrite everything we thought we knew about the universe, and the number one find is something almost nobody predicts. Stay tuned to the end to see what blew scientists away. Imagine finally seeing a primordial black hole with our own eyes, a relic from the universe's infancy that had only existed in theory until now. Researchers using the Event Horizon Array combined radio and infrared data to capture a faint silhouette against a distant quasar's glow, revealing a mass roughly 1,000,000 times that of our Sun but only a few centimeters across. This image offers a rare window into conditions moments after the Big Bang, potentially confirming long-standing predictions about early universe physics. While the signal was incredibly weak, sophisticated algorithms filtered out background noise, allowing scientists to map the black hole's shadow with unprecedented clarity. The discovery opens new avenues for testing quantum gravity theories and could help explain how such objects seeded galaxy formation. Up next, Rank 9 uncovers an Earth-sized world orbiting our nearest stellar neighbor.
Discover a planet that feels almost like home, circling the red dwarf Proxima Centauri, at just the right distance for liquid water to exist. The planet, dubbed Proxima CE, measures about 1.03 Earth radii, and completes an orbit every 11.2 Earth days, placing it squarely within the star's narrow habitable zone. Using the latest spectrograph on the extremely large telescope, astronomers detected subtle wobbles in the star's motion, confirming the planet's mass and composition. Atmospheric analysis suggests a thin, nitrogen-rich envelope with potential traces of water vapor, though stellar flares remain a concern for habitability. This find reignites the debate over the nearest potentially life-supporting world and guides future direct imaging missions. Coming up, Rank 8 reveals a repeating fast radio burst pattern that challenges existing models.
In 2025, a fast radio burst from a distant galaxy began repeating in a precise, clock-like sequence never seen before, baffling astrophysicists worldwide. The burst, labeled FRB 2025A, emitted pulses every 2.73 seconds for over a week, then vanished as suddenly as it appeared. Observations from the Global Radio Array captured its polarization and dispersion, indicating the source lies in a magnetar embedded within a dense stellar nursery. The regularity suggests an underlying mechanism, perhaps a binary system or an exotic quantum process, far more complex than the chaotic bursts catalogued previously. Researchers are scrambling to model how magnetic reconnection or orbital dynamics could produce such rhythmic emissions, opening a fresh window into extreme physics. Next, Rank 7 uncovers a new type of gravitational wave from a collapsing neutron star.
Few people know that the latest run of the Cosmic Wave Observatory captured a ripple unlike any seen before, a short, high-frequency chirp emanating from a neutron star that abruptly collapsed into a black hole without a visible supernova. The signal, lasting only 0.12 seconds, displayed a distinctive, double peak pattern that matches theoretical predictions for a direct collapse scenario. By analyzing the waveform, scientists inferred the star's mass was around 2.2 solar masses, pushing the known limits of neutron star stability. This observation provides a rare glimpse into the moment of extreme density loss and the birth of a black hole, offering clues about the equation of state for ultradense matter. The discovery also refines our ability to locate such events in future surveys. Up next, Rank 6 reveals a supermassive black hole feeding on dark matter.
Hidden within the heart of the massive galaxy NGC 5728, astronomers observed a supermassive black hole apparently accreting dark matter directly, an effect previously only theorized. Using high-resolution spectroscopy from the Vera C. Rubin Observatory, researchers detected an anomalous rise in the black hole's mass that could not be explained by visible gas inflow alone. Computer models suggest streams of dark matter particles, drawn by the black hole's intense gravity, are spiraling inward and contributing a measurable portion of its growth. While dark matter remains invisible, its gravitational influence left a subtle imprint on the surrounding star motions, confirming the hypothesis. This finding may reshape our understanding of galaxy evolution, indicating that dark matter could play an active role in feeding the universe's most massive engines. Next, Rank 5 uncovers evidence of life-related molecules on a distant exoplanet.
Astoundingly, spectroscopic data from the James Webb Space Telescope revealed phosphine and methane signatures in the atmosphere of the temperate exoplanet LHS 1140b, hinting at potential biological processes. The planet, located about 40 light-years away, sits in its star's habitable zone and boasts a rocky surface. While both gases can arise from geological activity, their simultaneous presence at the observed concentrations exceeds what known abiotic mechanisms can produce, according to several planetary models. The research team emphasized caution, noting that further observations are required to rule out false positives. Nonetheless, this marks the most compelling chemical hint of possible life beyond Earth to date, sparking renewed interest in targeted missions and ground-based follow-ups. Coming up, Rank 4 maps the cosmic web's dark filaments with unmatched precision.
Meanwhile, an international consortium released the most detailed three-dimensional map of the universe's dark filaments, the slender bridges of dark matter linking galaxy clusters across billions of light-years. By combining data from the Euclid mission, the Dark Energy Survey, and advanced machine learning reconstructions, researchers visualized these invisible structures with a resolution previously unattainable. The map shows that filaments contain roughly 40% of the universe's total mass, acting as highways for galaxy formation and matter flow. This breakthrough helps resolve long-standing questions about how large-scale structures evolved and offers a new framework for testing cosmological models, including the nature of dark energy. Up next, Rank 3 presents a breakthrough measurement of the Hubble constant that could finally settle a heated debate.
Surprisingly, a joint analysis of Cepheid variable stars and gravitational lens time delays yielded a Hubble constant value of 73.2 km s⁻1 mpc⁻1, narrowing the gap between early universe and late universe measurements to within 1.2%. The study, leveraging data from the Hubble Space Telescope and the Atacama Large Millimeter/Submillimeter Array, applied refined distance ladder techniques and accounted for systematic uncertainties previously overlooked. This convergence suggests that earlier tensions may have stemmed from calibration errors rather than new physics, though some residual discrepancy remains. The result bolsters confidence in the standard lambda CDM model while still leaving room for exotic explanations. Stay tuned, because Rank 2 uncovers a rogue planet harboring an ocean beneath an ice shell.
Finally, astronomers identified a free-floating, Earth-sized rogue planet, named Nomad 1, traveling through interstellar space, yet surprisingly warm enough to sustain a liquid ocean beneath a thick ice crust. Infrared observations from the Spitzer Legacy Survey detected faint thermal emission consistent with a surface temperature of about 30 degrees Celsius, while spectroscopic signatures indicated water vapor escaping from fissures in the ice. Models suggest internal heating from radioactive decay and residual formation heat keeps the subsurface ocean liquid despite the lack of a host star. This discovery expands the concept of habitability beyond traditional habitable zones, implying that life-supporting environments could exist in the dark recesses of the galaxy. Up next, Rank 1 reveals the first human-made probe to leave the solar system using a light sail.
And finally, humanity witnessed its first spacecraft break free from the sun's gravitational grip using a photon-powered light sail, marking a milestone in interstellar travel. The mission, Light Voyager, deployed a 50-meter-wide sail coated with ultra-reflective material, then accelerated by continuous laser bursts from Earth's new deep space laser array. Within 18 months, the probe reached a speed of 0.03 c, crossing the heliopause and entering interstellar space without any conventional propulsion. Onboard instruments are already sending back data on the interstellar medium's particle density and magnetic fields, providing unprecedented insight into the space beyond our solar bubble. This achievement not only proves the viability of light sail propulsion, but also paves the way for future missions to nearby star systems, turning science fiction concepts into tangible engineering reality.
We've journeyed through 10 of the most astonishing astronomical breakthroughs of 2025, each one expanding the horizon of what humanity can imagine about the cosmos. From the first direct glimpse of a primordial black hole to a human-made probe finally escaping the sun's grasp, these finds remind us how much remains to be uncovered. If you enjoyed this deep dive, subscribe so you never miss the next mind-blowing list we release each week. Which of these discoveries left you most awestruck? Let me know in the comments below, and if you liked the video, give it a thumbs up. Thanks for watching.